Here we go into what I like to call the rewrites. So in this video, what we're going to go over is how to take the derivative of functions that at first look like we cannot use the power rule to rock our derivatives on. But with a little bit of manipulation, a little bit of changing, we'll be able to find the derivative no problem. Let's check this out. So it says find the derivative of each function below. And again, I call them the rewrites. So looking at this, this is y equals the fourth root of x. It's not in the form of x to the n. And remember, our goal is to be able to get in that form because we know the derivative with respect to x of x to the n is n times x to the n minus 1. That's our power rule. So looking at this, if I rewrote it as x to the 1/4, sweet. Now we're in the form of x to the n, and we're going to go ahead and proceed like we know how with our power rule. So I multiply by 1/4, I get 1/4 x to the 1/4 minus 1, which is negative 3/4. And that's your final answer. If your teacher does not like a negative exponent, you'd rewrite that as 1/4's in the denominator, x to the 3/4. And some teachers even are crazier than that, and they want you to rewrite this with roots. Well, that'd be 1/4 times. This gives you the root index, which is the fourth root. That gives you the power, x cubed. So you can do it that way as well. All right, that's one problem down. On to this one. Again, it's not, at least this part is not in the form of a power, right? X to the n. So let's rewrite it. That can be rewritten as 3x to the negative 2 plus 5. The plus 5 doesn't worry us. We just need to know our constant rule. This we notice, sweet, is now in power rule form. So I'm going to multiply negative 2 by 3, which is going to give me negative 6. That's negative 2 times the coefficient 3 is negative 6. And then we're going to subtract 1 from this, which is equal to negative 3. 5 is a constant, and the derivative of a constant is 0. So that's why there's no 5 there. Some people, again, won't like the negative exponents, so we got a negative 6 in the numerator. The negative 3 applies to the x only, so that converts to x cubed in the denominator. That's it. Beautiful. So we've got ourselves some good work here. Why not box that answer? Why not? Anyway, in letter C, a different kind of format here. And people freak out when they see this and they're like, oh my gosh, how do I deal with this? Well, it's clearly not in this form. So what we do is we divide t into each piece. So I look at it like this. T squared over t minus pi t over t. Pi t. It sounds like a kind of tea you could sip. It would be quite irrational, no? It's terrible. Okay, let me continue with this. Clearly, I'm not a comedian. T squared over t is 1, right? We subtract exponents. 2 and an exponent of 1. 2 minus 1 is 1. So that equals out to t minus, the t's here will divide out, pi. Now, it's very important to recognize that you're not done. A lot of students, in my experience, will look at rewrites and say, oh, I'm done. I've rewritten it. Our goal is not to rewrite it. Our goal is to take the derivative. We've rewritten it so that we can take a derivative. So now let's follow suit. So this is equal to v of t. V prime of t is what we want, the derivative. And the derivative of t, well, keep in mind, that's t to the 1. So it'd be 1 times t. T to the 1 minus 1 is t to the 0, which is 1, minus a constant. That derivative goes to 0. All right, very cool, very cool. And it makes sense that this would be 1, by the way. Look at it this way. The slope of this, well, this t on its own is just a line, right? It'd be like y equals x. And the slope is always 1. Pretty stuff. Here, yeah, we've got individual components, but you can't take a derivative of each individual piece of a product. Reason being is, if you were to take a derivative of that, and then a derivative of this, and then multiply, you wouldn't get the same answer as if you distributed and then took a derivative. We must do the latter. We've got to distribute first. So I'm going to distribute as my manipulation. That's my rewrite. X squared times 3x to the 5th is 3x to the 7th, right? We're adding 2 and 5. When we have the same base, we add the exponents. And then x squared times 9x is minus 9x to the 3rd, because x squared times x is like doing 2 plus 1 in the exponents, x cubed. Again, we're not done yet. I'll find dy dx. So we use the power rule. So that's going to be 7 times 3 is 21. X to the 7 minus 1, which is x to the 6th. Beautiful. minus 3 times 9 is 27. Power rule again. X to the 3 minus 1 is 2. Sweet. Give yourself a little fist pump, maybe a double one. Yeah, you got this. All right, we're going to keep rolling with these rewrites. Y equals 2 over the cube root of x to the 4th. Whew, that's gross. Let's put it in power rule form. The 2's just chilling. So this is going to be x to the 4 over 3. Ah, now it's in this form. So I'm going to power down, if you will, use the power rule. I'm going to write this part out when I take a derivative, just so we do the work out. 2 is hanging out. It's the coefficient. 4/3 gets multiplied down. X to the 4/3 minus 1 is 1/3. Well, that's 4/3 minus 1. 2 times 4/3 is 8/3. So that's 8/3 x to the 1/3. Now, if your teacher's cool with the exponent being there, great. Some teachers will want you to rewrite that in what's called radical form. This would be the cube root of x. Y'all, I'm fine with you keeping it like that. Okay, this one, we're going to actually find there's a different way of deriving this in a few lessons down the road, but for now, we could rewrite it because it's really not in the form of what we need it to be in. So that 6 is just hanging out, but what I want to do is rewrite it as 6 times x plus 3 times x plus 3, and we're going to use good old foiling, right? Let's do some distribution. So that's 6 times, first is x times x, it's x squared. Outer is 3x, beautiful. Inner, 3x, also beautiful. 3 times 3 is the last. That's 9. And we condense everything. That's going to be 6 times x squared plus 6x plus 9. So I'm squeezing it in here to fit it on the screen. And then you're going to distribute the 6. Whew! It's a lot of simplifying. 6x squared, 36x. And if you're skilled with algebra, you won't have to show all these steps. I'm just doing it because maybe you're not feeling algebra today and you need to see it done out. 6 times 9 is 54. Okay, remember, even though you've done a lot of work does not mean you're finished. We've yet to reach our goal of taking the derivative. So let's do that. C prime of x is equal to power rule. Let's do it. 2 times 6 is 12. X to the 1 because you're subtracting 1 from 2. 36x is going to have a derivative of just 36. Two ways of looking at that again. That's like a line with a constant slope of 36. So the slope's always 36. Or you have x to the 1 and you did 1 times 36. X to the 1 minus 1 is x to the 0, which is 1. So you have no more variable. And the derivative of a constant, 0. So that's our answer right there. I likely would not leave a 1 there. I think that's kind of weird, leaving the 1 there. So let's get rid of that thing. Last but not least, what do we do when we have a situation where we get a variable over a number? The rewrite's actually quite simple. Rewrite it as 1/5 x squared, right? Dividing by 5 is the same as multiplying by 1/5. And when we do that, we see that we're again in power rule form. We're going to multiply by 2. So that's going to be 1/5 times 2, x to the 2 minus 1, which is x to the 1. And now let's just combine these two. That's like 2 over 1, so 2 times 1/5 is 2/5. X to the 1 is just x. Voila! Those are what I love to call the rewrites. It's all about manipulating so that you get to this form of a function and then take a derivative. See you next time. That was fun.